Hello and welcome to Math 135 Introduction to Statistics. This is your instructor Asmalaib and this is section 1.1. In this section, we are going to define statistics and statistical thinking, explain the process of statistics, distinguish between qualitative and quantitative variables, distinguish between discrete and continuous variables, determine the level of measurement of a variable. Statistics plays a major role in many different areas of our lives. For example, it is used by politicians to help them understand how the public feels about various governmental policies. Statistics is also used to determine the efficacy or the effectiveness of some experimental drugs. When you use statistics appropriately, it can provide a valuable understanding of the world around us. If it was used inappropriately, it could lend support to inaccurate beliefs. So, what is the definition of statistics? Statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusion. So, that last piece states that results should be reported using some measure that represent how convinced we are that our conclusion reflects reality. And the information we talk about when we mention that in the definition, it is the data that we're going to collect. And a key aspect of data is that data varies. In fact, data vary when measured on ourselves as well, because we don't sleep the same number time of hours every night, and we don't consume the same number of calories every day, for example. Data could be numerical, as in height, or non-numerical, as in gender. Let's consider the following scenario. You're walking down the street and notice that a person walking in front of you drops a $100 bill. Nobody seems to notice the 100 bill except you. Since you could keep the money without anybody knowing, would you keep the money or return it to the owner? Now, suppose you wanted to use this scenario as a gauge of the morality of the students at our school by determining the percent of students who would return the money. How might you do this? You could attempt to present the scenario to every student at the school, but this is likely to be difficult or even impossible if the student body is large, especially. A second possibility is to present the scenario to 50 of those students and use the results to make a statement about all of the students at the school. This leads us to the following definition. An entire group of individuals to be studied is called a population. An individual is a person or an object that is a member of the population being studied, and a sample is the subset of the population that is being studied. In our scenario, the population will be the entire body of the students at our school, and an individual will be a single student. And then a sample would be the 50 people that you are going to choose to represent the entire population. And in fact, a population, it is not only a group of people, it could be a group of anything, for example, cars, birds, animal species. The next definition that we're going to look at is descriptive statistics. Descriptive statistics consists of organizing and summarizing data. Descriptive statistics describes data through numerical summaries, tables, and graphs. So what we just did with the numbers with our previous example is exactly a descriptive statistics. We collected some numbers and we came up with a percent to represent the morality of the students at your school, which leads us to the next definition. A statistic is a numerical summary based on a sample. So in our previous study, if let's say suppose 49 of 50 students stated that they would return the money to the owner, we could present this result by saying that the percent of students in the survey who would return the money to the owner is 78%. And 78% here in this case is a statistic because it was taken based on a sample. Inferential statistics uses methods that take results from a sample, extends them to the population, and measures the reliability of the results. The accuracy of a generalization always contains uncertainty because a sample cannot tell us everything about the population. Therefore, inferential statistics always includes a level of confidence in the result. So rather than saying 78% of the students would return the money, we might just say we are 95% confident that between 74% to 82% of all the students would return the money. One goal of inferential statistics is to use statistics to estimate parameters. So, what is a parameter? A parameter is a numerical summary of a population, meaning the inferential statistics is about taking the result from a sample and trying to generalize that idea for the entire population, of course, using a level of confidence. By now, you could notice the difference between parameters and statistic. So, suppose the percentage of all students on your campus who have a job is 84.9%. This value represents a parameter because it is a numerical summary of the entire population. But if you take a sample of 250 students and then we find out that 86.4% have a job, this value represents a statistic because it is a numerical summary based on a sample. So, what is the process of statistics? The process of statistics basically is done in 4 steps. The first step is to identify the research objective. A researcher must determine the questions he or she wants to answer. Those questions must clearly identify the population that is being studied. The second step is to start collecting data. This data will be used to answer the questions that we have. 3, we have to describe the data using descriptive statistics, which will give us an idea about our data, just an overview. 4, we perform inferences. So here is an example to illustrate the process of statistics. Many studies evaluate better treatment programs, but there are few experiments designed to compare better treatment programs to non-therapeutic treatments, such as community service. Researchers designed an experiment in which 376 male criminal court defendants who were accused of assaulting their inmate female partners were randomly assigned into either a treatment group or a control group. The subjects in the treatment group entered a 40-hour better treatment program, while the subject in the control group received 40 hours of community service. After 6 months, it was reported that 21% of the males in the control group had further battering incidents, while 10% of the males in the treatment group had further battering incidents. The researchers included that the treatment was effective in reducing repeat battering offenses. So let's apply the process of statistics. The first step is identify the research objective. The objective in this study was to determine whether male accused of battering their inmate female partners that were assigned into 40-hour batter treatment program are less likely to batter again compared to those assigned to 40-hour of community service. The second step is beginning to collect information or data to answer the question in the previous step. The researchers randomly divided the subjects into 2 groups. Group 1 participants received a 40-hour batter program, while Group 2 participants received 40 hours of community service. 6 months after the program ended, the percentage of males that battered their inmate females partners was determined. Step 3, describe the data, organize and summarize the information. The demographic characteristics of the subjects in the experimental and control group were similar. After the 6-month treatment, 21% of the males in the control group had any further battering incidents, while 10% of the male in the treatment group had any further battering incidents. The last step is to draw conclusions from the data. We extend the results of the 376 males in the study to all the males who batter their inmate females partners. That is, males who batter their female partners and participate in a batter treatment program are less likely to batter again, meaning that we are performing inferential statistics in the last step. Once a research objective is stated, a list of the information we want to learn about the individuals must be created. Variables are the characteristics of the individuals within the population. For example, recently my son and I planted a tomato plant in our backyard. We collected information about the tomatoes harvested from the plant. The individuals we studied were the tomatoes. The variables that interested us was the weight of a tomato. My son noted that tomatoes had different weights, even though they came from the same plant. He discovered that variables such as weight may vary, and variables could be classified into two groups: quantitative and qualitative. Qualitative, or we call them categorical variables, allow for classifications of individuals based on some attributes or characteristics, while quantitative variables provide numerical measures of individuals. Values of quantitative variables could be added or subtracted and provide meaningful results. Here is an example to distinguish between qualitative and quantitative variables. Researcher Elizabeth and others studied factors that affect the eating habits of adults in their mid-30s, and the resource is stated. Classify each of the following variables considered in the study as qualitative or quantitative. So the first variable is the nationality of the adults in the study, and that is qualitative because it represents a characteristic. The next variable is the number of children. So that is quantitative because the number of children could be 0, 1, 2, 3, etc. Household income in the previous year. That is quantitative as well because we can count it. It could be 50,000, it could be 60,000, etc. The next variable is the level of education. That's a characteristic, so it's a qualitative variable. And the last one is the daily intake of whole grains measured in grams per day. That is quantitative because we can measure it and it is countable and we can count it. It could be 0 grains. It could be 150 grams of grains per day. Further classify quantitative variables into two types: discrete or continuous. So a discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. And the term countable means the values result from counting, such as 0, 1, 2, 3, 4, 5, etc. A discrete variable cannot take on every possible value between any two possible values. A continuous variable is a quantitative variable that has an infinite number of possible values. It can take on and can be measured to any desired level of accuracy. So here is an example to distinguish between discrete and continuous variables. In the previous research done by researcher Elizabeth, let's classify each of the following quantitative variables considered in the study as discrete or continuous. Remember that we had the number of children and we said that is a quantitative variable because we can count 0, 1, 2, 3. And clearly that is discrete because we can't have 1.5 children. Household income in the previous year, it was a quantitative variable as well, but this is continuous because we could have 50,325.76 cents as an income. The last variable was the daily intake of whole grains. That is continuous as well because we could have like 75.6 grams of grains per day. If observations, a variable assumes is called data, while gender is a variable, the observations, male or female, are data. Qualitative data are observations corresponding to qualitative variables. Quantitative data are observations corresponding to quantitative variables. Discrete data are observations corresponding to a discrete variable. Continuous data are observations corresponding to a continuous variable. A variable is at the nominal level of measurement if the values of the variable's name, label, or categorize. In addition, the naming scheme does not allow for the values of the variables to be arranged in ranked or specific order. A variable is at the ordinal level of measurement if it has the properties of the nominal level of measurement and the naming scheme allows for the values of the variable to be arranged in a ranked or specific order. A variable is at the interval level of measurement if it has the properties of the ordinal level of measurement and the differences in the values of the variable have meanings. A value of 0 in the interval level of measurement does not mean the absence of the quantity. Arithmetic operations such as addition and subtraction can be performed on values of the variable. A variable at the ratio level of measurement, if it has the properties of the interval level of measurement and the ratios of the values of the variables have meaning. A value of 0 in the ratio level of measurement means the absence of quantity. Arithmetic operations such as multiplication and division can be performed on the values of the variable. Let's look at this example and determine the level of measurement of a variable. A study was conducted to assess school eating patterns in high school in the United States. The study analyzed the impact of vending machines and school policies on students' food consumption. A total of 1,088 students in 20 schools were surveyed, and the sources stated right there. Determine the level of measurement of the following variable considered in the study. Number of snack and soft drink vending machines in the school. That is a ratio. The second variable is whether or not the school was a closed campus policy during lunch. That is at the nominal level. The next variable is class rank, freshman, sophomore, junior, senior. That is at the ordinal level. And the last variable is the number of days per week a student eats school lunch. That is ratio. That's at the ratio level.